Hey all, this is Mark at Omni Embedded, and we're continuing on with video training. We're in Chapter D, which is not what it once was. Back in Chapter C, this was going to talk about the data center and RTI blocks, but we've decided to squeeze in a couple of short chapters on the tools that we're going to be using as we flow through the rest of these chapters. So this has been rearranged, and we're going to go into ProDev Intro for this chapter and look at the ProDev tool. This is a list of topics that we're going to pop through. One is project creation. We've already done this in Chapter A, but we'll do it again. There's an LED flash feature that's in the starter project. That's going to be removed, and then we're going to put it back in using the tool and some hand coding. Okay, we're going to start a new project. This is really going to be the same starter project that we used in the installation chapter. And as I had said before, I like to put my Eclipse project files in a different folder than the actual source code. So this is the folder for the source code. This is where I'll create the Eclipse workspace. And this is our business logic folder and library. So now that I've created that, I'll bring over, or I've already brought over the tool, and we'll create a new project. So it needs the location that you want to put your project, also the location of your business logic library. I'm going to use the folder name as the project name. We're using a K64 Freedom, which is a Kinetis product from NXP. And the file, or the project is now created. We'll see the files in here. And the next thing to do then is to start our Eclipse project. All right, now that that's open, we'll do some project setup. I've got a particular way I like to arrange it, so we're going to import the Vtrek preferences. And there's one more thing I like to do under Window, Preferences, General, and Workspace. I like to click these two items because that causes the refresh on your folder view, the Project Explorer view, if anything modifies files outside of Eclipse, which our tool does. So that gives you a quick you can notice it quickly if a file changes or a file is added. It'll show up within about 5 seconds in here. Let's import the project now. That's located here. And then we'll give it a test build. Okay, now that that has built, I'm going to show under Source Product Logic Feature. This is the flash LED feature that flashes the green LED on and off. So offline, I'm going to remove all of this from the project, and then we'll recreate it. Okay, now that that's done, I'm going to open up the schematic for the Freedom board so that we can find the green LED pin. And that happens to be right here, and I'll blow that up a bit so we can have a peek. It looks like it's on port E, pin 26. And we're going to go in to ProDev, and first we're doing a debug build. We're going to make sure that digital outs are turned on, and they are. And so next, I'm going to go into the digital out configuration area, And we need to add a channel. It looks like we already have channels for the red and blue LED. And so we're going to insert a new channel below. And this is going to be for the green LED. So the update rate, or the task that we want to tie it to, 10 milliseconds is plenty fast. This is the time it takes from the update of the data item to when it actually gets pushed to the output pin. Output phase is fine. We said this is port E, pin 26. And so we'll select that. Now as far as the data item, we'll look at output examples. We've got one for the blue and red, so I'll need to add one for the green LED. Add new. The group is going to be digital outputs. It's a Boolean. And I'll just be consistent with what we called them over here. It's not safety critical. And we've finished that update, so now it shows up here. And that also means that I should be able to refilter and pick it up in this list. So now we've got the green LED. From the schematic, we can see that this is actually an active low pin, and that means that in order to turn the LED on, we're going to bring current through the LED and then to ground on port E26. So we call that a negative true logic, and we use positive true logic in the framework, so that means if it was active high, we would check this, but it's not active high, it's actually active low. So we'll leave it alone. That means when we push this true, the light will go on, and when we push it false, the light will go out. Before I hit the OK button, I do want to go in here and watch what this does to our configuration file. So this is the file where all of our configuration data is in one monolithic structure. And I want to run down to where the digital outputs, which is right here. And so far we see that there's the blue and red LED. And when I hit OK on these, we should see an update on this. And so what we see is that the data that we just entered has been inserted into this structure, and we've now mapped our digital output pin to a data item. We can also see, if we go up to Data Center to its config file, that a new data item's been entered into this table, which is the green LED. So the next thing I'm going to do is start a new folder under Product Logic and Feature Control. This is where the LED flash feature is going to go. So I'm going to give it that name, and in order to add that, we can go into feature, and it's now showing up here, but we also are going to need to add it to the properties list. So if we go in here and scroll down, you'll get into a section that says Project Directory Path. And we can see our folders. We're looking for feature, and there it is. So I'm going to add a new line, copy what's in there, and just bring it into here. And that should add the path for us. So now we've got a path to this folder. And at this point, we're going to use ProDev to create a new set of files, a CPP and H file. So in file templates, we want to create a singleton class. So I'll double click this. It wants to know where to put it. So let's point that out to it. We need to go to the F drive. Actually, probably would have been faster to do a copy and paste, but that's okay. Vtrek workspace, freedom, application, source, feature, and flash LED. So now that's in there, and the group is feature. The base name for this is, I'll call it LED Flash Demo. Or just Flash LED, I think. I will need a CPP file. It's not going to be a configurable class, and so I don't need a config.h file. So now that I've answered all the questions, it says the file was created. Let's go see if that's true. All right. If we open these, we see that we have a flash LED.h file and a .cpp file. And the constructor started. The open call, which is the call that we use to open singletons, is there, and that looks just fine. Cool. The next thing we need to do is go to a file called sysconfig, and this is in product logic, Vtrek config, sysconfig.cpp. It was already open. But what we need to do is add an open call to this file, and so I'm going to add the include to our new file. And I'm going to run down here and give it an open call where the features and controls are. So why did we just add this? Well, the sysconfig.cpp file is called during startup, so during product initialization. And all the components that are enabled in the build, the singletons open call is conducted here. And now that it's in here, the ProDev tool is going to see it, and you'll be able to enable and disable this component right through the tool. When you enable it, or I'm sorry, disable it, the tool will come into this file and put a disable comment in front of it, like so. And then if you enable it, it comes in and removes this so that it gets called during initialization. So we're going to build this now, even though we haven't put any code in the LED flash or flash LED component yet. We'll build it to make sure everybody's happy. Okay, it built with no errors or warnings. Let's just review what's happened so far. In the config data service config.cpp file, this was added by the tool when we pulled up the digital inputs or digital output channels menu and added our green LED. In product data items, we added the green LED data item or shared variable, and those are basically the two things that the build needed to be able to link and find everything. So at this point, we're ready to fill in the flash, the LED flash code, and for that, I'm going to use snippets to get most of this done. So we're going to need there's two possibilities that we could do. One is to go to utilities and see if there's any help. And in fact, there is. In controls, I believe it is, there's a util flasher. And so we could use this. But this is more so for a situation where you need a duty cycle and a period, and you need it to be fairly high resolution. Period is in milliseconds. And so this is one option. We could use this, but I'm just going to flash this at half a second. And so I'm just going to do that from a thread. And then we're looking to insert a periodic thread function. So we'll use this snippet tool. It's going to go into the flash LED. I'm going to call it flash. I want to do it at half a second, so we'll select the half-second task to attach our thread to. Since we're driving an output, I'll put it on the output phase. The task rate multiplier would be this value times whatever you wish to put in here. So if you wanted like 1 second, you could put a 2 in. We want to do it at 500. And I do want to enable the thread from the constructor, so we'll run that and see what it got us. So the snippet added this line, an include that we're going to need. It added this line, which is it's going to be the object pointer to this thread delegate that we're going to create. It also added the prototype. And then over here, we'll see that it added a line to create the thread, the periodic thread. And in that line, since we said we wanted it to be enabled, it put this in the parameter to enable it. This is the thread multiplier and so forth, entries that we put into the form. And lastly, it added the actual function itself. So the snippet tool did quite a bit for us there. The next thing we need is to become a writer of our green LED data item in the data center. And so we'll use this snippet. It's going into the flash LED file. I'll call it green LED. It's a Boolean, and it is an output, so we'll go from the outputs group and select green. All right, let's see what happened here. So we now have a write interface has been declared as a Boolean. And over here, we also have a line that gets the write interface. So we now have a pointer to the write interface for that particular shared variable or data item. So all that's left is to fill in the actual thread function. All we're trying to do is toggle that Boolean. So I'll do a put. And by the way, put and get are the two functions supported by a write interface. If it's a read interface, only a get. But in this case, we need to read it first. So I'm going to take our read DI call. And so this is going to read the data item, invert it, and then put it back as the inverted value, and then that'll flow down to the pin. So we'll try the build. Okay, looks like we got a good build out of it, so I'm going to download this and give it a whirl. Okay, I'm running it, and I'm getting a half-second flash out of the LED, so it looks like that worked. Just to review what we've done, the only real code that was handwritten is this line of code. The files were generated through file templates, mapping the half-second or 500 millisecond thread, periodic thread, was done through a snippet. Mapping the data item as a writer was done through a snippet, and that left us with this line of code to have to implement. So I think that gets us through the objectives for this particular chapter. We've done all that's on the list, and so now we can move on to just a quick intro to the DDC tool. That's the next chapter, and we'll see you there.